Today I am going to discuss a proposed traceability system for animals. What are the general requirements of an animal traceability system? Firstly, the tags should be electronic. The standard is to use ICAR-approved RFID transponders. This leaves less room for error and also minimizes administration in data collection. Tags should also be tamper-proof, meaning that the tag applied to an animal should stay with the animal the rest of its life to ensure that the data collected for the specific tag number is the data belonging to the animal which carries the tag. Data collection should be easier than collecting data on paper. And lastly, uploading data to a centralized database should be easy. Data validation should be done on the server side to ensure that the user doesn't need to care about data issues. So how should such a system look like? Well, probably the most important component we need is the tag or the RFID transponder which will be applied to an animal. This will serve as the animal's ID and all data collected will be saved under this number. Then we need an compliant RFID reader to be able to read the RFID tag and collect data and save this to the reader's memory. To get the data from the reader, software is needed to download the collected data and to finally send the collected data to a centralized database on a cloud-based server. The data will then be available for authorized parties. The data can also be in some cases changed from the web interface and the data software can also reflect this. It's obviously also possible to integrate other data collection tools and make them compliant to such a system to work. Why do we need such a system? The lifetime of an animal can be summarized by a term called CTEs, which stands for critical tracking events. In the ideal world we would like to record all these CTEs to have all the data of the animal available. To be more realistic, however, the animal will firstly belong to a first owner at birth. Let's call this owner the farmer. This animal will likely be sold at some point in time to another owner. Let's call this the feedlot to get the animal nice and fat. Then the animal can likely be sold again to an abattoir, which unfortunately for the animal will be its last stop. We therefore want to collect the CTEs of the same animal from each different owner, to have, at the end of the animal's lifetime, full transparency of the animal's life. We can achieve this with a system like the one proposed. For example, a sheep, in this case, can be born, then the farmer collects data of this sheep and syncs the data with the centralized database. When the sheep moves to the next owner and the next, the same concept applies until the sheep reaches the end of its lifetime. So in this case data collection could therefore happen during the full lifetime of the animal. CTEs like birth, treatment and the departure of the animal can be recorded by the first owner. The second owner will take ownership of the animal when the arrival CTE is recorded. The second owner will then also be authorized to view the data recorded of this animal by the first owner. The same applies when the animal is transferred to a new owner. CTEs can be recorded and saved by the last owner until the end of the animal's lifetime. The goal of the system will be to have records of each CTE of each animal which was uploaded to the central database. The records allows the owners of the animal as well as the consumer to have full transparency of the animal's lifetime. As an example, an RFID reader from Agrident, the APR 500 is used to register and transponder. Under usual circumstances the transponder will be applied to the animal's ear, but you can get the picture with the video. The reader has a task-based data collection procedure which is programmable so to follow some workflow process. You enter some information on the device, can choose from pre-programmed lists, scan the EID and link all this data to the EID number. To illustrate movement, there is also a movement task which will be used to transfer animals from one user to the next. This is basically done to allow the system to authorize the next owner of the animal to the data of this animal. The APR luckily have a feature in the task called record loop, which scans tags continuously for situations such as applying some values to a bulk of EIDs. In the event of sickness etc., it's also possible to remove the animal using a simple task. The same applies for other certain kinds of CTE like health tasks like medical treatments and medical tests. Once it's time for slaughter, the animal's last true weight can be recorded to get a more accurate measure of dressing percentage etc. Animal's EID transponder is linked to carcass in supply chain. Hook transponders can be linked in system along the supply chain to maintain traceability of carcass. The meat is packed and NFC or barcode is attached to packed meat. We want to ensure full traceability along the value chain. An example of what data that needs to be collected after slaughter is shown on this report. This report gives the animal's ear tag, the grade of the meat, the live kg weight, which has been measured right before slaughter like on the video on the slide before, and the slaughter percentage. The animal ear tag number is then also linked to a serial number of the carcass packaging, for example. Now a small demo.